So now that I've got my part modeled up, I've got my solid model on the screen, and I've got my wireframe from solid visible on my screen also. We can start to prepare to machine the part. We're going to spot drill and drill the holes that are on the part. Before I can do any of that, I need to select a machine definition. To do that, I'll come up to the machine tab, and then over in the machine type region, you'll see mill. I'll select the arrow below the mill, and I have two options. I can choose the default machine definition, or I can select the machine definition from the managed list. I'll select managed list. That brings up this dialog box. I'm going to select the generic Fadal format 1 for X mill. And I'm going to add it to this field over here. So I select it from this field, select the add icon. It appears here in this field, and then I'll select OK. And what that did, now when I go to the mill icon and I expand it, in addition to the default machine definition, I also have the generic Fadal format 1 4-axis mill available from this drop-down menu. So from here, I'm going to select the generic Fadal format 1 machine definition. Now, it doesn't look like anything has happened, but a few things have happened. The toolpath tab is now available to me. And if I go to View, and in the Managers region, select Toolpaths, you can now see in my Toolpath Manager, I have a machine group. Another way to make the Toolpath Manager visible or invisible is hold the Alt key down and strike the O key. So that'll toggle the visibility on and off. Or you just come up to the View tab, and in the Managers region, you can turn Managers on and off from here. So for now, I'm just going to keep the Toolpath Manager visible. We'll need to make some changes to the default machine group or the Fadal format 1 machine group. To do that, underneath machine group 1, you'll see properties. Select the plus sign to expand the properties. I'm going to select files under properties, left click on it, and that brings up this dialog box. From here, I'm going to change a few things. The group name, we'll call this Fadal format 1. We can go into the machine and select edit. And what I want to do is I want to make sure that the default RPM capability matches what I have in my shop. So what I'll do is I'm going to expand the mill spindle group until I see VMC tool spindle. I'll double click on VMC tool spindle, and that brings up this dialog box. Now, the maximum spindle speed for this particular machine definition is 10,000. In our shop, we have 3 machines, 3 Fadals. 2 have 7,500 capabilities, and 1 has 10,000 capability. So I'm going to set this to 7,500. I'll select OK. And then I'm going to select OK again. That brings us back to this page. I'll accept the defaults and everything you see here. I have output operation comments to NC, that's checked. I'll go to tool settings. Default program number. This is where we can enter a 4 to 5 digit number. This will be the program number or the O word at the beginning of our NC file. So I'm just going to pull a number, 8,000. Other things that I'll change here, feed calculation, I'll set it to from material. For toolpath configuration, I'm going to check assign tool number sequentially. I'll check warn of duplicate tool numbers, and I'll check use tool step peck and coolant. From here, I'm going to go down to sequence number. These will be the line numbers in our NC file. I'll start with 1 and I'll have them numbered in increments of 1. Once you do that, that brings us to the material. If I look at the blueprint, this particular part is made from aluminum 6061-T6. So I'll start by selecting the material. I'll go to the select icon. That brings up the material list. Currently only have aluminum inch 2024 available to me. So if I right click in this field and then select get from library, I can select aluminum inch 6061 here. I'll select OK. While it's selected, I'll select OK again. And you can now see that this is the active material for this particular project. From here, I'll go to Edit. In this field, I can make an adjustment, or I can add -T6. For the base cutting speed with this project, let's use 400 SFM. And let's change our base feed per tooth / revolution to 8 thousandths of an inch. That completes the changes that I'm going to make on this page. From here, I'll select OK. We'll go to the stock setup. My stock plane is currently set to top. To define our part shape for verify, I'm going to use rectangular. And then there's different ways that we can define the shape of our part. In this particular case, I have a model on my screen that is an accurate representation of my part. So in this case, I'll go to select corners. You'll notice that these fields are all 0. So from here, I'll go select corners. And Mastercam is asking me to select first stock corner point. I'm going to select 2 points to define the length, the width, and the thickness of my part. I'm going to select points that are opposite of each other in all 3 axes. I'll select this point first. I'll let my cursor lock onto the endpoint, left click. To select opposite in all 3 axes, I'll come over to this corner. This is opposite in X and Y. And then I come down here, this would be opposite in X, Y, and Z. If I select the corners correctly, the values that now occupy or populate these fields should represent the dimensions of my part. From here, I'll select OK. I'll save my work. We're now ready to start selecting tool paths.